Hello. Well, it's been a while, but welcome to another Kaggle walkthrough of one of the more basic datasets. Today we're going to be analyzing the housing prices data competition on Kaggle. This is a great way to help you learn how a data scientist like myself might approach a problem similar to this. This should be very similar to my analysis I did on the Titanic dataset, where I walk you through how I approach an analysis from just starting out with a new dataset all the way to the submission of results. This one is just a little bit more advanced and focuses on regression techniques rather than classification like the other one did. Here, I cover basic data exploration, creating a data pipeline, feature engineering, model building, parameter tuning, and ensembling. You can follow along by cloning the notebook that I use on Kaggle with the link that's in the description below. If you find this useful, you can also support my work by liking this video and also upvoting the Kaggle notebook. I have quite a few other free resources and notebooks for learning on my Kaggle profile and on GitHub, so if you liked this, definitely check those out as well. What's special about this analysis is that I also talk about how I would use new tools like ChatGPT to assist me. Throughout the video, I talk about the points where I either used AI to help assist me on the project or where I could have used it to facilitate my work. Now, let's jump in. All right, so this is the project we're going to be analyzing today. I will share a link to the data and everything in the video description below. Something I like to do before I start any analysis or any Kaggle competition or Kaggle notebook is I like to read everything I can about the overview, the evaluation, look at some tutorials, and also look at the data. So something I went through, I actually didn't go through that many tutorials because I thought it would be better for me to have a fresh perspective. It'd be better for you all to let me take a fresh take on this. But after the fact, I reviewed some stuff and I actually made some changes and revisions. So I actually think that if you're a more advanced data scientist, that's a really good way to learn, is you essentially do your analysis first. And then after the fact, you can go back through and you can see what could be improved upon. And I actually did make one major change that really helped my performance by looking at other people's code. And of course, I will credit them when we get to that point in the video here. So the description, so we can use Python or R. We want to essentially be able to predict housing prices based on a bunch of different features. We're going to be evaluated by root mean square error. So when we're doing this analysis, we probably want to use root mean square error as our measure of merit, or how we're going to evaluate all of our models that we're using. I also really like to look at the data. That's something really important. So we're going to be doing essentially all of our analysis on the train set, and then we're going to be trying to predict this test set and uploading the results. We also have this data description that talks a lot about all of our features in a bit more detail, which is really important. And we have this sample submission data, which shows the format that we should be submitting our results in. So in this data set, something that I noticed immediately is there's a lot of different fields. So we can look at the shape of the data set once we start doing the analysis, but something that is important to me as a data scientist is using my time efficiently. So if I wanted this analysis to take a really long time and in theory do the best possible analysis I could, I would go through each one of these individually and really think about it carefully. But a lot of the time as data scientists, we're under time constraints. So we might not have the ability to go through or the time to go through all of the different features and really make the best judgment about each one of them. So I looked at a couple that I thought were particularly interesting, and I also used my analysis to inform which variables that I might be able to manipulate or do things with. I also don't really have a lot of subject area expertise around real estate and housing. I know like probably around the same amount as the average person who is looking to buy a home but has not purchased a home yet. So those are things that I, as someone trying to analyze this data, would be looking into to understand better. You know, if I was really doing this super serious for my work, I might read a bunch of articles and try to understand what is a half bath versus a full bath, or what do people in the industry say about garages versus enclosed porches versus, you know, is a pool worth it based on maintenance and all of these types of things. Something that we'll also see is this data set is relatively small. I think there's only around 1,400 or 500 different properties that are evaluated. So maybe I would try to pull in additional data from the outside world that I can find to improve the quality of this analysis. This data description is really useful also. So it says within each of the categorical data features what each of the different codes mean. And this is important because when we read this in, we're seeing 20, 30, 40. The programs we're using, they interpret this as numeric data rather than categorical. So we really need to make sure we go in and we adjust this to make it categorical rather than numeric, so it has the correct meaning for our models. So I would go through and briefly explore all of these things. I think this is pretty important. Just reading through and having a high level understanding of what types of data points are in our model and what each of the individual columns might mean. I personally, we're talking about how I would use AI tools, how I would explore these a little bit differently. When I started this analysis, I essentially made a prompt on ChatGPT where I said, hey, I'm going to read in a bunch of different columns in the data and a bunch of details about the columns. And I'd like you to just keep that in memory for if we wanted to analyze this data. So now my ChatGPT, the AI that I'm working with, I'm using the GPT-4 like kernel, I guess, for that. It has some understanding about the analysis that I'm doing, and it can help me perhaps make more informed decisions or help me streamline what I'm working on here. All right, let's jump into the notebook here. So again, there are a few things that I touch on in the notebook, and before I get started, I always like to give myself a task list. So I go through and I tell myself, I write down, usually in comments, what I'm expecting to do with the analysis. So in this one, I wrote down these 7 things. So I want to do some basic data cleaning and feature exploration. I want to do a more traditional exploratory data analysis. I want to do some basic data engineering, some model experimentation and parameter tuning, feature engineering, ensembling, and then I want to submit. Then within each of those, I'll write comments and I'll say, hey, I need to do these 5 things for me to feel like I've completed this task. So I go through and I create that structure before I start. And then when I approach the analysis to actually do it, I have a task list, again, to just go through and knock out those things rather than getting to a point, thinking about what I have to do, and then starting. That, to me, saves me a lot of time, and it helps me structure a lot of my analyses. So in this video, I want to also emphasize why watching the video is actually useful rather than just going through the notebook. So I talk a lot about how I approach the problem, just like I was talking about how I create the task list. I also talk about how I consider using AI tools like ChatGPT to work on and solve a problem like this. I mean, this is something that has changed how I work from 5 months ago. The way I code now and the way I'm approaching this problem is very different than I would before these tools were available. And I think these tools are super helpful in getting work done and creating value through data, but also for learning different things. So I'm going to integrate some of that into this video and talk about where I myself have used ChatGPT in this analysis. I'm also going to talk about why I made certain design decisions, so why I decided to do things a certain way. So data science is open-ended. 100 data scientists could do this analysis 100 different ways. And so there's certain choices that I made that might not be right, might not be wrong, but might be different from other people. And I like to talk about how there's some ambiguity in any of the decisions we make with data science. And then finally, at the end, I'll talk about some ways that you can improve upon this analysis. So I think it was fine. I was in like the 60th, 70th percentile with my results. But I'm going to talk about some ways that you could improve these results if you were to take this and make some changes to the code, and if you were to iterate on this a little bit more. And I fully expect you to do that. That's a legitimate project. That's something that you can share. It might not be useful to share it in your portfolio. This is a pretty normal project, but it is something that can 100% help you learn. So let's start working through the code here. So the first thing we do here is we import the relevant packages. So we use NumPy and Pandas for data manipulation. We use Plotly graph objects and Plotly Express to do data visualization. I import SciPy to do some normalization that I'll talk a little bit more about later. And then I use this IPython display to make this more visually readable for us. I 100% use ChatGPT with this IPython display code to make it more readable. I actually think that's a perfect use case for this, and I'll touch a little bit more on that in a second. So some people like to put all of their all the packages they use up front and load them in at once. I think that's totally fine. But for the sake of teaching, I think it makes more sense for me to have most of the packages around the code that I'm using them for, just so it's a little bit less confusing what we're reading in. So just that's the syntax that I'm going to use. You don't have to do that when you're doing your own work. You know, it's probably better to actually put everything at the top, especially for creating requirements files or things like that. Now let's go into some of the more traditional code. So in our data exploration, we're going to import the data. We're going to look at some summary statistics. So we went through and looked through all the columns and through some of the details here, but we want a little bit better idea of what the shape of the data is, what we can expect, if there are outliers, if there are null values, those types of things. So we're also going to explore these null values, and we want to see, hey, maybe we shouldn't include some columns, you know, they're almost all null, or if it would be useful to include those or not. So the first thing we do is we read in the data. In order to get the path on Kaggle, there's a couple different ways. So the first way, I'm going to slide this over here, is we're going to work from this test data, and we can just copy the path and copy and paste it in to here. That's probably the easiest way to do it. But you can also just get like the system output. And usually at the top of each Kaggle file, when you create a new one, you can just run that line of code and it'll show you the path to the file. This next line here, I'm going to run the first couple columns. I'm not going to run all the code because when we actually get to training the model, that takes quite a bit of time. This code is some I got directly from ChatGPT. So this makes it so we have essentially scrollable tables like this, rather than them not showing us all of the data. I could give you an example of that. Yeah, sure. I might as well show you what that means. Not particularly important for the analysis, but here we go. So you see how, again, we can scroll through this. If we just take this summary stats and print it like that, it goes down all the way, and it's just less convenient to view it in that sense. So I thought that was a useful design decision and a perfect use case again for ChatGPT. So this isn't code I'm going to write all the time. This is particularly useful just for teaching, not necessarily for my work. And I don't really want to occupy my brain with any of that stuff. Have ChatGPT write it. It's useful, but it isn't an integral part of my analysis by any stretch of the imagination. So right here, all I did was, I'm actually just explaining this code. So what we're going to do is we're going to get our numerical features and we're going to transpose it. So this is numerical features. It has in the rows, the count, mean, standard deviation, min, 20th percentile, 50th percentile, 70th percentile, and max. And then on the top, all the columns are the different numerical columns. This code here is essentially just getting all numerical features. We're transposing this describe function here so that all those are in the rows, and then we're putting it into this display so we can use the scroll down and view it that way. So we can start looking and analyzing all of the different data points. You know, we just might want to look at and see, hey, like what is the average for some of these things? Like lot area is interesting. What's the standard deviation? Wow, the standard deviation is really big here. What does that mean for us? And so we can just start exploring and analyzing all these things. If I was doing this for work, I'd probably want to know the majority of what these things are and understand them better. For the sake of this analysis, that would be pretty time consuming. You know, there's a lot of different columns. If we go and we just wanted to look at the shape of this data, maybe we wanted to look, you know, we can see there's 1,460 rows and there's 81 columns, right? So that means there's 81 different features. That's a lot of time. You know, you really could dig into each one. It might take an hour to purely understand each one. And, you know, if you're really trying to understand this from work perspective or develop subject area expertise, it could be worth spending that time and getting to know these things. For a project like this, probably not worth it to get that in depth, but it is also useful to think about, you know, how we approach these types of problems. Something we might also see in here is that year built, for example, is a, you know, it's a continuous variable, but do we necessarily want it to be a continuous variable, right? Or year sold or some of these types of things. Year sold, I mean, there's so much fluctuation in the housing market, especially during, I think 2008 was the housing bubble, that you might actually want each year to be a category rather than a continuous thing, because continuous variables implies there's some sort of relationship between them, whereas each individual year might be completely independent based on market factors or things along those lines. So those are decisions that we want to think about when we're analyzing and looking through this data. The next thing we're going to do is we're going to run this for the categorical variables. So we're going to see all of the different categories that we have. And as we saw before, some of the things that should be categories, like the subclass, we need to make them into categories because they're currently encoded as numeric. So those are things that we'll want to adjust and take note of now, and we'll do that in the feature engineering spot. So I just did that a little further above. We don't need to redo that. Next, we want to look at null values. So we'll run this code, and we can see the null values in the data set. And then we can also just look at this is the percent of missing values. So like 93% of these data sets have null in alley. So, what does that tell us? Do we want to remove alleys altogether? Maybe we should just have alley as a categorical, and the alley will be, it'll be 1 if there is an alley, 0 if there's no alley, and that might give us more information about the data set itself. So next, this isn't really necessary, but I thought it would be useful. I just went through and looked at a sample of the data that had null values. If you have less null values, or there's columns and there isn't something like alley that's almost always null, this could be more useful just to explore those specific null values. All we're doing is we're looking at the rows that do have a null value, and we're selecting from that subset. And then we're putting that into this function that we created to make it scrollable. I probably should go up here and talk a little bit more about some of this code. I realized I didn't really walk through that much. But for data, the selecting data types, we can do numeric, like we did up here with NP number, or we can do objects, which are all of the other types of data in the data frame, usually categoricals. This t.t transposes the data frame. So it goes from my example above, where all of these are on in the row area, and it switches them to being in the column and just transposes the data frame that way. So that's something I actually learned from ChatGPT. I didn't know the .t did something. It's a little embarrassing, but we learn as we go, and I'm glad I know that now rather than not knowing it later. So next, I just got a list of all the columns. We can just explore that. I kind of use this just to copy and paste if I want to get a couple of the columns and I don't want to worry about misspelling them. So now something that's important that we do is we explore the dependent variable in our data set. So we need to ask, should it be normalized? And then we can go about normalizing this dependent variable. This is something I did after the fact, so I didn't think about it really for this analysis. But when I went through some of the other analyses that were out there that were scoring significantly better than I did on the competition, this is something that made a lot of sense. So this is the notebook I got this from. It's a really good notebook. He scores quite high on the leaderboard. So it's worth, after the fact, going through and exploring other people's work. I think when you're learning, it's okay to just do stuff on your own before consulting other work and stuff, just so you can bounce stuff off. But if I'm actually doing data science work, I'm looking at a bunch of resources. I'm looking at a bunch of other people's code, trying to get the best results possible. I also thought this was useful for other people when you might not have a notebook that does something similar, for me to go through this with just my own approach. But this was definitely something useful, and I want to be clear that I did add this in after the fact. So what we're doing here is we're creating two graphs. So we're creating a histogram as well as a QQ plot, and that shows the distribution and the skew associated with the pricing of the houses. So as we can see, there's a ton of right skew in this distribution associated with sale price, and the QQ plot, so if there was no skew, it would be the purple dots would be right in line with this green line. So that suggests that we should probably use like a log transform on the data just to make it fit a more normal distribution. We're going to do that a little bit later. This code looks really confusing, right? All these data, all of this stuff that comes in. Honestly, it started out, I basically just wrote this line. So we're using plotly graph objects. We're taking the sale price as the X. We're setting the number of bins. We're calling it a histogram. And that's all I put in. I put that into ChatGPT and I said, hey, essentially like give it a dark theme. Also add a trend line. And I want the colors to be green and purple. And I iterated a couple times and it produced these two visualizations. I personally think this is, again, a really good use case for ChatGPT. There's a lot of different plotting libraries out there. You have Matplotlib, Seaborn, Plotly, like we're using here. The list goes on and on. There's even like ggplot for Python now. And I want to be able to use all of them. I don't necessarily want to have to know how to use, like, to learn everything there is about each individual tool. So I think using ChatGPT or these AI tools to create visuals is very, very effective. It saves you a ton of time. And the cool thing about visualizations are that you can look at it and say, hey, this matches up with what I think it should be. So there's some validation built in just by looking at the visuals. You probably should, as you advance, learn one of these packages well so you can debug more effectively. But I think in the learning process, being able to create powerful visualizations like this, just like without having to know that much, is something that can accelerate how you learn and help you create impact or help you, learn these things and see these things more effectively really quickly. So, that's something that I teach this now so different than I would, again, 5 months ago before these tools. But I think that this evolution is really useful and really practical. So next, let's go into what questions do we want to ask of the data. So this is an exercise I do for every project that I have. I sit down and I say, okay, I'm trying to figure something out about price that's relevant to me. With all this information at hand, what things would I like to know and understand better? And I went through and I actually asked ChatGPT after I read in all that data, hey, what questions would we like to answer? And it came up with about half of these, and I added a couple of my own. So how does the distribution of dwelling types relate to sale prices? Does zoning impact sale price? Does the street and alley access type affect sale price? What's the average sale price by property type? Is there a correlation between property age and sale price? Is there a correlation between living area and sale price? And does price change year to year? So I went through and I created this list for myself that we can go through and answer each of these individual questions. I solved this in the same way that I solved the other, that created the other visualizations, where I wrote the very basic code. So, I wrote essentially this: go figure the data into the bar chart, what was going in, and I let ChatGPT improve the quality of the graph. So again, it looked pretty basic, just the bar chart, and I had it update the theme and put in the labels and those types of things. So we can see here that their single family homes are the most important. These townhouse E, which is townhouse end units, is the second most popular. Duplexes are the third most common. Normal townhouses, so not end units. And two family, I don't know what two family, let's go. So 2FM, two family conversion, originally built as a one family dwelling. So those are generally the least common. And then what we wanted to know is how price impacted that. So something that's really interesting is single family homes and townhouse end units are pretty comparably priced. But townhouses and townhouse end units there's a huge premium on these end units. So if I'm someone interested in maybe investing in real estate, maybe when a new development goes in, all of the townhouses are the same price, but that end unit, it might be worth more in resale market, wherever that might be. That's something that tells me useful information. Next, we wanted to see how zoning impacted the sale price. And again, I essentially just wrote some of this code. So we group by this, and then we're going to use Plotly Express to create this graph of the average sale price by zoning. So I thought I would, instead of using graph objects, use Plotly Express. I can use two different tools. And I had, again, ChatGPT just get the theming, and create, like, for example, these dollar sign formatting. That would have been a pain in the butt. It was really useful for improving the quality of this data visualization. So let's look into what the different zoning things are. So we can look at zoning. Okay, so we can see we have, I'm gonna pull this out here. So we have C, which is commercial. I'm trying to get this all in one thing. FV, which is floating village residential. Don't know what that is. RH is residential high density. RL is residential low density. And RM is residential medium density. And then it looks like there wasn't enough data for some of these other data types. You know, what was FV again? Floating village residential was the highest price. We should probably do distribution of these as well, like how many data points there were. But this is pretty interesting. So again, from an investing or a buying perspective, these are probably going to be relevant in our model. Now let's keep going down. So we wanted to know about street and alley access and if there was if there were impacts on sale prices. We're essentially grouping by street, and then we're looking at the average sale price for those, doing the same thing by alley price, and we're going to create two different graphs here. I use the same process that I described before for all of these graphs. Again, I could walk you through each of the individual graphs, what all of the different things do, but in a future where we have AI, we have some of these systems, I don't know if it's necessarily even worth it. Like, I think we're going to be doing a lot more of this iterative coding and looking and getting feedback. And, maybe it would be worth it to talk about, some of the fundamentals of Plotly, but I would rather you be equipped to use any of the visualization tools, even if it's through an interface with AI. So I'm probably not going to focus as much on this. If there really is an interest in me going into the details of all of the visualization tools like this, just let me know in the comments. But as of right now, I'm probably gonna lay off of that and just work through this. So we have the average sale price by street. You would imagine paved roads, paved streets are worth more. Not much of a surprise there. Same thing with alleys. Next here, we have the average sale price by property shape. I did myself a favor this time and actually put what these were, so I don't have to keep going back and forth. So IR1 is slightly irregular, IR2 is moderately irregular, and IR3 is completely irregular. And so we see here, so IR1, IR2, IR3. So IR2, so like slightly, moderately irregular, are actually more generally fetch more on the open market. And then property contour, let's go back here and explore that. Land contour is the flatness of the property. So we have banked. So this is banked. What does banked mean? It's quick and significant rise from street grade to building. We have hillside, significant slope from side to side, low depression, and then flat. So hillside seems to be at the highest value, low and then level. I guess that's not super surprising. You want to have a view down, but it's interesting that data supports this. And if we were a realtor, I would imagine I would find this fairly useful. So let's keep going here. Keep going down. This one was pretty obvious, but I was interested. So we make a new variable here. That's a little bit different. So we create property age. We just take the year sold minus the year built. So we want the age when it was sold, right? Like how old it was. And we're using a core plot here rather than a bar chart. And so we can just see all of the data here. And we can see that there's generally a downward trend associated with price and age. So the older houses are generally sold for less than the newer houses. The idea of like an antique where we see a massive spike after a certain age mark is not present there. We also wanted to look at something as simple as living area and sale price. This is a lot clearer of a relationship, and maybe I'll have ChatGPT go back in and add in a trend line. That's something I can do relatively easy with these tools. It'd probably take me like 30 minutes to figure out on my own if I hadn't done it before, if I didn't have them. So to me, that's a pretty interesting one. Is that okay? This is probably going to be meaningful in the data set here. And then the last thing I wanted to do is have a little bit of a different graph. So we're going to look at the box plot of price over the years. We also actually get to see what years are in the data set. So 2006, 2007, 2008, 2009, 2010. Obviously, I think 2008 was the housing bubble burst. And so it's interesting to see, or maybe it was this whole period actually. But, there was a massive variation in 2007 of pricing. Obviously, the pricing in 2008, 2009, 2010 decreased quite a bit there. So we can get a lot of information about this. Might tell us something about how the individual year is a continuous variable. The year sold might not be as good an indicator as a relational variable, like a continuous, compared to a categorical variable where each of these are counted as independent events. So let's keep going. The next thing that we want to do here is to actually clean up this data and make it usable in a model. So we did some stuff like creating this variable here, and that's something that we're going to do that a little bit later. But we want to create these. We also want to potentially normalize the data based on the models we were using. We might want to impute some of the data for the null values. We also might want to scale the data based on the types of models that we're using. And eventually we also might want to one-hot encode the data. We're actually definitely going to want to do that. In my ML process course, we talk a lot about these. We go into all the different ways to scale, all the different ways to impute, all the different ways to encode. If you're interested in that, you can either check out the course. I also have all of the code that we use for the course and the resources we use for the course completely for free on my GitHub. That goes for both the ML process as well as our algorithms course that we recently released. So, obviously I love it if you purchase my courses, and I think the value's there because we explain everything, but there's a lot of free stuff there as well that can 100% give you a lot of really, really high level education and insight into this type of stuff. So what we're doing here is we're creating transformers, and we're creating, right here we're creating pipelines. So pipelines essentially just let you run two different or as many as you want. It lets you chain actions. So the data that goes into the imputer then goes into the scaler, and then it outputs it. This is just a really clean way to chain functions together, or to create what's known as a data cleaning pipeline. You could even put your model being trained at the end of these pipelines and run it all together rather than running these things in steps. So I like creating pipelines for my data cleaning so that when we start with our trained data, we put it through this pipeline, it gets output the data that we use to train our models. When we run the test data, we put that test data through the exact same pipeline, and then it means that it will essentially guarantee that it works in our model unless we botch something. So that's a really good practice for continuity. It's a really good practice for making sure that your code is scalable and repeatable, and it eliminates a lot of issues there. So what we're doing here is we're creating a numerical transformer. So this is going to act on all of the numeric data in our data set. So we're going to impute all of the numeric data with the average, and then we're going to scale the data. Here, we're going to, for the categorical transformer, this works only on our categoricals. We're going to impute all of the null values in categoricals with a constant. So if it's null, we're going to treat that like it's a new category. We're also going to one-hot encode, which means we're going to create dummy variables. So let's say we have three categories that things could be. So hot, cold, room temperature. This makes our data set now have three columns, actually two columns, one that's hot and one that's cold. And the last column will be essentially if it's 0 in those two other columns, we'll know that it's room temperature. If there are null values, we can have 3 columns. And if it's 0 in all those columns, then we would know that it was a null value, and that's accounted for in the model. The next thing we're going to do is we're going to split our data into the categorical columns and the numeric columns. And then we're going to drop our dependent variable. Then we're going to create this preprocessor, which is a column transformer. So a column transformer lets you choose which columns you want to adjust. So we're going to only want to, for the numerical transformer, to adjust the numeric columns. And for the categorical transformer, we're only going to want to act on the categorical columns. And this pass-through just means that all of the data is going in and all of the data is coming out. We're not just returning the columns that we transformed. So we can add an additional pipeline. This step, I guess, technically isn't necessary. Usually you would just add your model, that your trained model, that you'd want the pipeline to go through, and you'd run the pipeline and it would produce a result. So you would just have everything packaged into one thing. I like to pre-process the data and then test all my models, and then eventually maybe at the end throw it into the pipeline. That's how you would generally, in theory, productionize something. You use maybe more fancy tools, but in theory, that's how it would work. So now what we're going to do is we're going to create X and Y values. So we're just taking our data set, we're dropping the price, we're taking the sale price, which is our dependent variable, our target variable, and we're going to take the log of it. So remember, that's essentially because we found that it was skewed. This should normalize the dependent variable, and it will, based on my doing this problem, it'll give us better results. We're now going to take X preprocessed, and we're going to fit transform based on the pipeline that we created here. It's going to run this processor, which is this column transformer. So our data will now be completely cleaned through imputing and scaling, and imputing and one-hot encoding. So later, we're going to do some more data cleaning, manipulation, feature engineering. And in theory, I could go back here and make adjustments to this pipeline. For the sake of teaching, I'm going to completely copy this pipeline and iterate it different times so you can see where the changes are made. So the next thing we're going to do is we're going to start our model training. So we have linear regression, random forest, XGBoost, and then we're also doing in a little bit we'll do an MLP, which is essentially a neural net, but it's done on the CPU. We're not doing advanced TensorFlow or Keras, but we'll see how it compares to the other results. Especially with this small of a data set, I think it's probably overkill to use one of the more advanced models. For this data preprocessing step, I tried using ChatGPT. I didn't have a whole lot of success. It got me some framework, but I found that for me to get the exact steps that I wanted for my data, I had to be pretty hands-on here. I'll link the documentation to sklearn pipelines and categorical transformers. If you really want to dive into that, I think that'll be useful. Admittedly, this is not in my ML process course yet, but I'm working on that segment, and hopefully I'll have it in there within a week or two of this video coming out, because after doing this project, I was like, man, this is really important. I haven't been using these as much as I should. So I thought it would be useful to use a linear model, and then random forest and XGBoost. Obviously, tree-based models are a lot more generalizable, have less constraints associated with them. And so I just wanted to compare these three. I feel like I'm plugging my courses a lot, but in our ML algorithms course, I go through and we explain all of these different models in a lot of detail, so you can understand, hey, when would be a good idea to use linear regression? Why would random forest make sense for something? Why would XGBoost make sense for something? And we go through how you can train all of these, which I also think is pretty valuable as well. But in the GitHub, I do have details and kind of exhaustive parameter tuning for all of these. So you can just go there and just copy and paste that. If you want to use these models, you can copy and paste all the parameter grids for them. I went through, we created some parameter grids for each of these. We use threefold cross validation. And then I have essentially uh, this going through and using grid search, which means it tries all of the different permutations of these for each model and returns the best results. I'm not going to run this because it took a little while, but XGBoost produced the best results with these parameters. Realistically, I also used ChatGPT to create this code. I said what models I was using. I asked it to create the parameter grid, and I asked it to train the grids and produce the best results and the best parameters. I also kind of think that this part of data science, like the optimizing and the model fitting and tuning, that's something that is going to be not obsoleted, but it's something that will be going out of vogue over time. I mean, this is something that like AI or AutoML or these types of things are good at. So this is less artistry. This is pure science. And this is something that I feel comfortable saying, hey, like have a machine do the majority of this. It saves me a lot of time. So, obviously feature engineering, which is something we'll talk about later, that's something that I think is really difficult for machines to do. And that's something I would encourage other people to focus spending a lot of time on. Even the data visualization, although you're not necessarily like coding the visuals, I think it's really valuable to aggregate and build that skill, even if it is through telling an AI system what you want, because there is tremendous power in those visualizations still. This, I feel it is a little bit more like utilitarian, like you're just, there is some artistry in like choosing the parameters, but I think that'll be less and less over time as you get really like good rules of thumb. The next thing I do is we're going to do an MLP regressor. We copy in the data. This is something we need it to be scaled. So that's something I made sure I did. We didn't actually do any more scaling because we scaled it in our pipeline, but I just copied the train and tested. I, in theory, could have used just train and just X test, but I think I was feeling a little bit lazy because all the code is already written. We go through, we look at, we set the random state so we get similar results every time. We were running into some issues, I think, with alpha or with the learning rate, and I extended the number of iterations of the model to 10,000. And this is an early stopping parameter. So if the results don't improve for 3 straight trainings, it will just stop. And then we initialize the learning rate at that value. Again, in the algorithms course, I go into detail in all the parameters, but essentially these are just 4 different like architectures that I tried. So this neural net has like 10 nodes in one layer. This has two 10 node layers. This has 3, and this has just 1 layer of 25 nodes. We tried 2 different activation functions, ReLU and TAN. ReLU is usually the most common used now. And we use the atom optimizer, and then we set alpha, which is the normalization parameter, to try these different ones. And we try 3 different learning rates here. We do the same thing, grid search, we fit, and then we try to look at what the best score is. At least in this one, it didn't perform that well. I did find out later that my alpha values were not optimal. So I expanded these later, and we ended up getting a lot better results. But that's something that I just needed to experiment to really find more additional details about. So something you might have noticed right here about linear regression is that the linear regression results were unbelievably bad. And that's because we were feeding in so much data, and also a lot of the variables were highly correlated. So I didn't do a core plot because there were so many variables and it would have been really messy. But this is something, for example, if you have a large yard, you're probably going to have a lot of house square footage. You're also probably going to have a lot of bathrooms. So because of the multicollinearity in the data, we ran into some pretty big issues with linear regression being useful here. So something I wanted to try to do to see if it would clean things up was a principal component analysis. So principal component analysis essentially is that's a data manipulation technique that makes that gives you a certain number of features, and it tries to uncorrelate the data. So what we do here is we looked at how many rows would, I'm sorry, how many different like new variables would it take to have 90%, 95% of the data like saved, and we'll just take that many, and essentially we'd be able to now feed into the linear regression variables that were not correlated like they were before. So we create this PCA, and admittedly, my explanation and understanding of PCA probably not the best it could be. I don't actually use it that often, but for this use case, it was pretty practical. Just to hedge myself, I'll throw in some links about how PCA actually works and what it is in the description, and maybe I'll even tag it at the top of the screen. But so we add PCA to this pipeline. So we have the preprocessor. Now we just add in PCA, and then we can transform this data so it's XPCA. So we run the exact same models now. I shouldn't have to re-explain all of this. And I wanted to see if the results were any different. So I should probably go up there. So it's like 0.16. So the linear regression was way better. So we're getting 0.16 instead. I think the random forest and the XGBoost were just a little bit worse. Yeah, it looks like they were just both a little bit worse. But the linear regression, we fixed that problem with multi-collinearity. Now when we run the MLP regressor, this time I knew a little better and I fixed the alpha values, and we ended up getting slightly better results than we had before. I think it was 0.23 that we saw before. So now I went through and I wanted to see, based on the training that we did, how would we perform if we were projecting on our y-test. So y-test is not to be confused with test over here. We have not read, not to be confused with this test. This test is only to be used when we're submitting. The y-test we created was right. Well, this is for the PCA. The y-test we created was right here from our training data set. So we split our training data set into additional train and test sets. And so like the y-test here is technically an additional validation set for us to evaluate how well our model training did. Like in theory, we probably could get slightly better results if we didn't split it, just because we'd have more data to train on and we're working with a sample data set. So that's something I probably could improve upon, or you could improve upon if you wanted to make this better. But I thought this was pretty useful just for us to get a status check on how we were doing. So as we can see, XGBoost without PCA was actually just a little bit worse than XGBoost with it's actually a little bit better than XGBoost with PCA, but linear regression dramatically better when it was normalized like that. We also wanted to look at the MLPs, so our little neural network, and with PCA it looks like our MLP was just a little bit better. So we started to understand something about our data. Maybe PCA is better for some, maybe not better for others. And if you wanted to use PCA for some of the models, but not some of the other models, you could build a pipeline to do that. So let's keep going down here. This is where I start getting into feature engineering. So, earlier we talked about how, some of the things were not encoded correctly, right? We had, I forget what piece of data it was, but it was a numeric rather than when it should have been a categorical data set. So we can go through and start correcting some of these, some of the data around that. So I wanted to explore just some of these different data points, and we can go through and look at all of them here. There was a couple that I thought were pretty useful to transform. Again, I asked ChatGPT for some of this, and it didn't really give me great results. So I went through and built some of these custom variables. So the first one that we already saw, I built property age, We have total square foot, which is the basement square foot plus the first floor and second floor square footage. We have total baths. We have, has the house been remodeled? Um, does the house have a second floor? Because we were looking at getting these derived from other things. Does it have a garage? So we're creating another categorical from a numeric. We want to convert this year sold to a category. I don't remember what most sold was, but we turned it to a category. Year built category, and this MS subclass as a category. As you recall, this was a numeric before. So we're creating a couple more features that would be relevant here. The way we're going to do this is with a function transformer. So it just takes this function in, and it returns like where we're including the data frame, and it returns all of these new features that we've created. So if you wanted to go in and just add more features, which I highly recommend you do, you would just put them in here. You would add them to the new categorical or new numeric columns, and then it would automatically be integrated into your pipeline. So that's one of the beautiful things about creating pipelines, is that you really only have to adjust them in one place, rather than me having to go through and like change code all the time in all of the different feature engineering steps. So has remodeled, has second floor, and has garage. Those are the categorical variables we're adding. Property age, total square foot, total bath, year sold category, most sold category, year built category, and MS subclass category. So because I'm curious, we'll look at most sold. I can't remember what that was. Month sold. Okay, there we go. Yeah, so like seasonal month sold might be useful. That was pretty obvious. I probably should have known that one. All right, now let's go down here. We're essentially just rebuilding this pipeline. I could have put all of this above in that previous data processing step, but I thought it would be good just to put it in here. So what we're going to do now is we added those. I added this line of code to append these new columns to the categorical lists. And then we essentially just go down here and add this feature engineering transformer before that preprocessor code. So if we make a new component, like we want to do another feature engineering step, we don't have to go and rewrite this preprocessor code. If it comes before or after, we can just put it in here and it'll run it in sequence. So again, I cannot stress how useful these pipelines are. And I think it's really worth it for you to invest time getting a little bit better at those and practicing those. That's something, I mean, I guess you could ask GPT to put something in a pipeline, but to make sure they work, make sure they work reliably, is pretty useful skill to develop. All right, with that being said, we're going to do the exact same thing. We're going to go ahead and train these same models and see if our feature engineering gets us a little bit better results. I really should have just had like a running list of the code to see if we could do a little bit better. But so let's see here. So 16.3, 15.2, and 13.5. So we had 16.4, so linear regression is a little bit worse. Random forest did a little bit better. And then I think that did the XGBoost did a little bit worse. So, getting varying results. I encourage you again to experiment with additional features that you create. That'll probably help quite a bit. Next, we're going to go through and run the exact same thing for our MLP regressor, for our neural net. I changed some of the activation functions here. I was a little curious if we can improve. So this isn't an apples to apples comparison of the other ones, but I added a sigmoid activation function. I also changed the alpha to go all the way up to 100 to see if that would help with anything. And we changed the learning rate initiation to 0.1 instead of 0.001. So if I recall correctly, this did a lot better than our previous iterations. I just encountered a lot of errors because since some of the parameters weren't optimal, it just made it really long. And we got the by far our best MLP results here. All right, so I think it was changing the the alpha and maybe the initial learning rate. Oh, the solver was different. So SGD is stochastic gradient descent, which for it's not cutting edge. Like Atom Optimizer, if I recall correctly, is more commonly used, but maybe since the data set is so small, gradient descent worked significantly better. Who knows? Here we go through and we check and see how our results did again. Okay, so we saw that we did a lot better with our MLP. Now we actually want to start getting prepared to submit here. So what we're going to do is we're going to read in our test set. And, we saved ourselves a ton of time engineering this test set by creating the pipeline. So we're just going to run the test set through our pipeline. And now our data is pre-processed. It's ready to go into our models. So now we can just run the predictions on the test set and see how we do. Okay, so we're going to prepare some of these different data sets for submission. So we're going to do an XGBoost submission. So we're taking the pre-proc data, or making a prediction based on the feature engineered XGBoost, and we're going to take the exponent of this. So this makes it go from our log prediction to our exponent prediction. So we have to undo the normalization that we did initially on the sale price, right? So that's going to reconvert it back into something that's usable in the prediction. Right here, we're just going to get the data set ready for submission. So it needs to be in a specific format. So we need to have an ID, and we also need to have the sale price prediction that goes in. So we essentially, if we look at the sample of the submission, we have two columns, the ID and the sale price. Right here, we're going to create the CSV. If we wanted it to be our actual submission, we would change it to just submission.csv. I just wanted to save these results. I submitted them all on my own independently to see how they did. We're going to do the same thing for random forest. We're going to do the same thing for MLP. And then we're going to do the same thing for a ensemble model here. So right here, we're just taking all of our results and we're averaging them. So this is the most basic ensemble you can do, and we'll see how the results performed on that front. And then the last thing we're going to do is we're going to do another type of ensembling, which is stacking. So we're going to take the results of our three models and we're going to run them through another predictive model to see how that performs. So what we did here is essentially we created three different types of models. So we have another neural net, we have another linear regression, we have another XGBoost, and we're going to run the results of our three models that we're choosing through all of these to see which one produces the best results. Again, I didn't write this code. I had ChatGPT write this code because I wanted it to all be done at once, but I thought that this would make the most sense. I go through in the ML process course through all of our ensembling techniques that are relevant. There's really only the two. There might be one more that I'm not thinking of right now, the averaging and the stacking. And we see that the XGBoost ensemble by far produced the best results. So all we do here is we go down after all the training. We have the the best model from that stacking regressor, produce our predictions, and then we put it into the data set and then we submit the results. So we can see, let's see if I can find all of my submissions real quick. Let's see here. We can look at my submissions. So I submitted quite a bit. I think this was my best result. Yes. So it turned out I submitted everything and the best result was the just MLP prediction without the additional ensembling. That happens sometimes. I think we can go to the leaderboard and see where that stacks up. So, it was like 800 and Oh, it didn't take, oh, there we go. Yeah. Like 876 out of maybe like 4 or 5,000. So, not the best out there, but pretty good. Let's talk about some ways that you can improve upon these results. So I only used, I think it was 4 different models: linear regression, random forest, XGBoost, and a neural net. You could try different modeling approaches. You can try maybe support vector machines. You could try maybe like light GBM or some of these other models. You can also do more feature engineering. You could explore that. You can explore different ensembling techniques. You could explore maybe normalizing some of the other features that have skew outside of the dependent variable. There's a lot of different things that are available to you, a lot of tools at your disposal. Heck, you could even ask ChatGPT how you could improve upon these things. I think that that's, again, a really good learning resource, something I've relied on a lot more heavily in how I code and how I do projects like these. So hopefully this was useful. Hopefully this helps you understand how you would approach a problem like this from a data scientist perspective using ChatGPT, and also how you can continue to expand upon this analysis. So thank you so much for watching, and good luck on your data science journey.